a bit about the program that we are planning and that is available for sign up. And then Sri will give you an example of a case study and a very specific data science application, which is on some actual investor data, Edgar earnings filings. So this readily available accounting data. Now, Sri Krishnamurthy is someone who I've known for a long time now, and he's a real expert in data science. And he's someone whose firm we have chosen to partner with to help us deliver this particular data science offering. And one of the reasons that we chosen Sri is that he's someone who combines expertise not just in data analytics, but also in investment. So as you saw, he is a CFA charter holder, but also has a whole wealth of experience in delivering specific data science courses, teaching at some leading institutions, Northeastern University, on master's programs, MBA programs. He's a writer for Wilmot Magazine, one of the leading quant forums. And therefore, we're very pleased to partner with Sri and his team at QuantUniversity in this offering. A little bit of housekeeping about today's session. So you will find that there is a Q&A and a chat button at the bottom of this of your screen. So what's great is if you can perhaps in the chat section, I see some of you have done this already, if you're able in the chat section to tell us where you're coming from, that'd be fantastic. So which country you're joining from, that'd be really nice to see. I can see a few people who've said hi in the chat, that's great. So Farhad, you said hi, excellent. You can answer where you're from, fantastic. And then if during the session you have questions, can you please put those in the Q&A function, which is just to, in my screen at least, just to the left of the chat function. So if you can reserve the chat function for general chat like this, for where you're from, Cape Town, Uganda, Nigeria, fantastic. But you'll put your questions in the Q&A section. That will be fantastic. Okay. Actually, there's a good example. Actually, we have a question here, which is about whether this course is appropriate for people without prior coding experience. I can answer that right now. Actually, yes, it will be appropriate for people who don't have prior coding experience, because Sri will be talking us through that from scratch. But in general, we'll be answering questions towards the end of the session. But if I see a theme developing in this Q&A box, then I will be happy to raise it to Sri if it's appropriate to answer it during the course of the lecture. So I think that's probably enough in terms of housekeeping. So thanks very much for listening to me for those couple of minutes. Sri will now take you into the detail and the depth, and you'll see just how expert he is in these areas. Thanks so much, and we'll talk later.
Thank you so much, Richard, and welcome everyone to the session. And I am very pleased to kind of talk about some of the programming we have been doing. And Richard and I, we go a long way. I presume some of you must have listened to our sessions we did during 2020, which is available on the CFA Institute website, wherein we kind of talked about the data revolution and some of the aspects of data science and machine learning. So what I wanted to do today is to give you, a view of why this whole data science and the data revolution is something you need to care about as an investment professional. As you all know, the world has moved on from traditional modeling and just looking at statistical data and looking at the information which we typically see in magazines and in newspapers. Today, information is at everybody's fingertips. You more or less get the same information which is available to a very large investment house, which has invested tons and tons of resources on infrastructure and analysis. The world is changing really fast, and you need to make sure that you're kind of putting all the interesting information into your analysis and ensure that you are taking care of the fiduciary responsibilities you have been bestowed upon, and making sure that you're analyzing the requisite information and putting together the requisite analysis so that you can make the right investment decisions. Now, how has the world changed? In today's session, what I'm going to do is just give you a little bit of a preview of how the world has changed with respect to analysis, with respect to technology, with respect to data science, and give you the reasons why you should be thinking about upskilling yourselves with Python and data science. I'm also going to show you a preview of one of the case studies we have developed for this course, which is starting on May 25th. And hopefully that'll kind of give you the reasons why you're looking for to enhance your knowledge in data science and machine learning, and hopefully join us in the next few weeks through this course. So I'm so glad to see all the countries represented in today's session. It's kind of exciting to kind of look at the interest in various countries and all the investment professionals wanting to understand what is it all about when we talk about the data revolution. So I'm just going to step back and kind of, look at the last 100 years on how things have progressed, right? So we all knew that when people were inventing new things, they were thinking about how can we make this faster? How can we make this better? How can we make this cheaper? And the first industrial revolution was focused on leveraging power. We typically talk about horsepower, right? So when we talk about power, we say the horsepower. And that was because we were using animals to help us kind of lift different things, move various aspects of if we wanted to move something from one place to another. And then we realized that we could leverage water, we could leverage steam, and we could do things much, much faster and better because of these technologies. And then came the second industrial revolution, wherein we could potentially think about optimization, which meant that if you had a process in mind, what's the best way to leverage the resources at hand and design processes so that you could basically create much more than what was possible with traditional processes. The Fords of the world created a revolution wherein you had mass customization, you had assembly lines, and you were thinking about leveraging electricity and the various other innovations to make sure that you can develop the various things, which was not possible with just traditional power. And then came computers, right? And we were realizing that, in case we had to do certain calculations, we had to go through the whole process of building out the requisite calculations without intelligence. But with computers, you could start building smarter algorithms. You could leverage the power of compute to do things much faster. You could distribute various things. And as things have progressed towards the fourth industrial revolution, we are seeing a huge emphasis on automation, artificial intelligence, machine learning, to leverage all the information which is out there to try and build out processes which are optimal. And the combination of human intelligence and machine intelligence is where we are looking at to optimally use as we build out our various processes. So it's not far off when we are going to see all these technologies being realized. There's already talk about flying cars, and there's talk about all the things you would potentially see in a Jetsons cartoon. But the question is, how will the financial industry leverage all these innovations? And that's where we're going to focus on in this particular course. Because many times we kind of think about all these cool innovations and say, okay, so how can we leverage it today? Well, maybe we're not there yet in all the realms, but we definitely have a lot of power available in terms of compute. We have a lot of smart algorithms available. Data has significantly increased, and you need to have the processes in place to leverage all the information to get you the investment edge. So let me kind of give you a little bit of perspective on where the world is going. So this was a graph which I pulled out from the WIPO's website. And just to kind of give you an indication of how machine learning has progressed over time, you can see that in the left hand, many years between 1962 and until the early 90s, there wasn't very much in terms of scientific research happening in the area of machine learning. The reason being, there were a lot of concepts and people had ideas, but there was no way these technologies could be implemented. But then came the revolution. So you could see that between 2000 and 2017-ish timeframe, there was a significant increase in interest in research in the area of machine learning and AI. And that's kind of noted with this exponential rise in the publications. But the more interesting aspect is in the patent filing. And this is different from that of just scientific publications because companies are realizing that they can get a competitive edge by building upon this scientific research and protecting their intellectual capital through filing patents. So you see a significant number of patent filings in this time frame in the area of artificial intelligence. And you can see the specifics, areas like neural networks, support vector machines, rule-based learning, deep learning. All these areas are significantly being researched upon, and a lot of practitioners are leveraging these ideas and applying them to specific technologies, and they are capturing that through IP, and they're leveraging it for competitive advantage within their organizations. Now, you must have all seen the job boards of the day. If you go to any investment house website, you'll probably see a lot of positions open in the area of machine learning and artificial intelligence. In fact, in the last 4 or 5 years, we have seen a significant rise in the availability for these jobs, especially when there is data science, machine learning, and artificial intelligence involved. And why is that so? And we'll kind of understand it through an example so that you can get a feel for why you should be thinking about data science and machine learning. So let's kind of go back to 2018. And this was pre-Tesla, rather pre-Twitter, when Elon Musk actually sent out a tweet on August the 7th, basically saying that he's going to take Tesla private for $420. Now, a couple of things to note. This was 9:48 a.m. California time, and he sends out this tweet. And later, Bloomberg put out a post, and you could see that by 12:48, this is the East Coast time, this particular tweet was already on Bloomberg event-driven feeds. So what we are saying is within half a second of Elon Musk tweeting, everybody had this information in this world. And the question becomes, what are you going to do with this information if you have exposures to Tesla? Now, it's a very interesting problem because now you're going to be able to process this information and then see what the exposures are and take decisions the traditional way. But guess what? The market impact would have already happened by that time. And that's the reason why you need to understand that sometimes it's not just feasible for humans to process the information and take decisions. You will need machines, you will need algorithms to do risk management, to understand what's actually happening in the market, to distill and process that information. And that's why we are seeing what's called as a data revolution. And let me kind of give you a little bit of context on the kinds of technologies which people are talking about. Now, when I was a quant at Citigroup, and when I was building models the traditional way 15 to 20 years ago, most of the training and most of the technologies we were using was mostly in the left side of the spectrum, which was basically the traditional factor models, stochastic modeling, Monte Carlo simulations, different derivative pricing aspects, and distribution fitting, primarily coming from the statistical end, thinking about, well, here's a sample from a population, what kind of models can I develop, and how can I leverage that information in order to potentially predict a particular price or do risk management with respect to simulations. In today's day and age, we have a ton of data available. We have alternative data sets. The number of financial assets have significantly grown. There are significant correlations between different kinds of financial assets. You had to think about prediction. You had to think about real-time analytics. You had to think about potentially leveraging natural language processing and other kinds of alternative data available out there. You had to think about processing all this information. In today's day and age, guess what? With all the inflation and supply chain shocks, there are a lot of companies which are leveraging satellite information to track the ships in the water. And also with the geopolitical shocks we're seeing, there's been a lot of surveillance on what's actually happening. So you're seeing a confluence of all these technologies kind of come into play, especially when you need to understand what's actually happening in the world. And what that means is the data scientist of today is leveraging all these technology innovations and bridging that into the investment world. So in fact, the 21st century quant, as I call it, is going to be someone who understands the financial modeling, who understands the context of innovations in the financial world, but can leverage data science techniques and apply them appropriately for a particular job. Now, you may be wondering, well, data science is there. You can potentially just do a Google on data science, and you could potentially find a ton of resources you can go with. Well, the challenge there is, if you do not have the context, you're just going to be reading through technologies, and you may not be able to apply all these aspects when you think about applying them for your particular job. And then financial data is not like a traditional computer vision problem wherein you have a real good quality ground truth, and you're trying to make sure that you're fitting a model to whatever you've already seen. A cat is a cat, but yesterday's financial performance of a particular asset doesn't give me very much information when I'm predicting potential stocks value in the future. Well, let's kind of give you a little bit of perspective on the kinds of things which people talk about, and then I'll kind of tell you a little bit about what the program entails. Now, you must be wondering, well, how do we put all these things together? And I kind of talk about this virtuous circle of machine learning and AI, which basically has three components. And the first component is this notion of big data, which is the 4 V's, where you're seeing a significant amount of information come into play today. In fact, we are generating so much information and we are storing it. Many times we're not even processing it. We are generating data. When I'm driving in my car, I'm basically telling Google and other entities where am I, the latitude and longitude of where I am constantly. And various resources are sending me updates on a constant basis. So there's a lot of information exchange which is going on. On the other hand, we have a lot of varieties of information. In the past, we were just thinking about CSV files and Excel-based methodologies to typically work with data sets. But today we have geospatial data, we have voice-related information, we have social media, and a lot of different sources of information providing you the variety. And then the velocity of information. As I mentioned to you in this Tesla example, there's so much information coming at us like a hose, and you should have the processes in place to make sure that you can leverage all that information. And then the veracity. How many times have you heard of a particular announcement just to realize that a few hours later that the announcement was false? The fake news aspects, which gets amplified on social media. Now, do you take decisions based on a social media tweet? Well, that depends on what the source is, and do you trust the source? So the veracity of information becomes important. And to contextualize all these things, there are algorithms and frameworks which are being created in the open source realm. And that's the fascinating part of today's innovation. 20 years ago, you had to go to a large enterprise to source any technologies. You had to go to maybe a large Microsoft or an Oracle and license their technologies, and then it was a whole process. In today's day and age, with the rise of fintechs, everybody more or less has the same technology stack. Everybody has the same access to the compute power. When I go to Amazon or a Google or a Microsoft and say, I want to get this kind of a computer with this much memory, with this much GPU power, I get access to it immediately. I don't have to think about ordering any hardware locally and work towards it. On the other hand, the software revolution has picked up significantly. And the reason why we chose Python for this course is within 5 minutes, you can get the latest and greatest packages on your laptop or desktop running. And all these packages have been developed by professionals and researchers and students throughout the world, and they have been vetted out by multiple communities, including the large technology houses, and it's just reduced the bar of access. You can technically get a fully fledged development environment running within a few minutes, which means that you have all the computational algorithms at your fingertips. Now, what do you do with it? How do you access the data? How do you process it? How do you contextualize it? How do you apply it? That's all left to you, but you don't have to think about the technology problem. And that's the beauty of a language like Python, because Python is not just a programming language wherein you will have to think about, oh, I need to learn how to write loops. I need to learn how to write various data structures. Well, you need to understand a little bit of those. But what does Python provide you? And it's the power to access these libraries, the power to access the data sources which are out there, the power to access alternative data sets and bring it into your investment workflow. And many times, traditional tools like Excel will not get you that much flexibility and the power to access these libraries. And that's one of the reasons why a lot of companies are going towards making Python as a tool of choice in order to build out algorithms, in order to access other kinds of systems, and also to build systems which can potentially be deployed into production. Okay, so now that I've given you a little bit of context on these technologies, there are a lot of applications, as you've seen, which leverage data science and machine learning. But I will kind of contextualize this with respect to an investment workflow. I gave you an example, in the second industrial revolution, if you will, wherein the Fords of the world were building out pipelines so that the assembly lines, basically, so that you could build out hundreds and thousands of cars, basically making a car an accessible utility for many families. And that's what's happening with the data science revolution today. We are developing these investment workflows, these data science workflows, which makes access to information potentially to everybody. And it depends on what are you going to be doing with that information. There are all these investment processes which potentially have been figured out by various companies, but you have the power to build your own. You have the power to leverage the information, and you have the power to do with the outcomes of this information. With that, I'll tell you a little bit about the program we have put together. And this program has taken many, many years based on the industry feedback, based on the teaching I do with various universities and with various companies. And we have taken Python and we have put together multiple case studies so that you can understand the power of the language, but also contextualize it to various examples and case studies so that you can take these skills to your job after you complete this program. Now, the program itself is structured as 4 modules, and this is an introductory course, just to be clear. As Richard was mentioning earlier, the goal is to orient people who are new to Python and give them sufficient tooling and also examples and case studies so that they can understand the power of the language and build out the requisite knowledge so that they can expand it and apply them when they start kind of practicing these skills in their chosen profession in terms of either research or in terms of building systems. Now, the 4 modules will either be delivered over 4 weeks, depending on the program specific you're going to choose, whether it's the US or the Asia Pacific or in the European time zones. And basically, you will have the whole materials delivered through the Q Sandbox, which I'll give you a little bit of a demo later. And if you complete all the 4 modules, you will get a certification of completion at the end. And it's a live program. We will have a lot of interaction between various participants in this workshop setting. And it's online, and you will be able to dial in like what you're doing today, but you'll have the interaction with the instructors, you'll have interactions with other peers who are participating in this program. And we also plan to host office hours after each class so that in case you're doing your practice and you want to get any kinds of help from us, you'll be able to bring those into those office hours, and also you'll have support offline through email. Now, as you know, Python has multiple packages. And if you just Google Python and the number of packages, you'll probably find more than 10,000 packages out there. So where do we start? And that's where we have basically distilled the requisite packages you typically need for putting together programming. And what we have done is we have created specific modules. And in the first module and the second module, you'll kind of get to know the constructs of the language. And the way we are going to be doing this program is we'll introduce you to concepts, but immediately follow up with the lab and a case study so that you can operationalize those concepts. So you can build upon the skills not only just by sitting back and listening to these lectures, but you will get to see the examples, you'll get to try out a lab, and you can basically reinforce the knowledge through a case study. So once we kind of understand some of the basics, we will delve into some of the data science methods. And this is basically to give you the investment workflows and the constructs on how do you put things together, how do you understand the relationships, what does it mean when you talk about implementing quantitative methods, what are the common libraries, how do you invoke these libraries when you build out examples, and we'll showcase that through an example for visualizing various stock portfolios. And in the third and the fourth module, we'll primarily focus on various ways of operationalizing this through various examples and case studies. Now, as you all know, machine learning is becoming extremely popular. So we will basically choose some of those techniques in the machine learning realm and use Python to implement some of these methodologies. And we will do a lab on clustering, and then we will also apply some of these techniques in the context of time series forecasting. And we'll give you an example on how you can potentially leverage machine learning techniques for predicting stock returns. And then the fourth module is all rolling up your sleeves and working hands-on. So you will have to kind of operationalize many of these concepts you've learned till now, and we will take a case study, and I'll just give you a brief overview of one of the case studies we're going to discuss, but then we will also try and reinforce it with another portfolio management problem. And then we will recap with giving you a little bit of direction on where the world is going, what are the various frontier technologies you should be aware of, and how do you kind of upskill from there on. Once you have gotten the basics of the language, some of the basic case studies, how do you build your knowledge base from there? So that's kind of the structure of the program. The first cohort is starting on May 25th. We're very excited to see a whole diverse set of countries represented in this cohort. And also we are excited to see all the participants who are expressing interest, and they have joined into the program. And the program is going to start at 9:30 on May 25th, and it's going to be a 4-week program. And the EMEA, which is the European time zone, so we wanted to create 3 cohorts so that it's convenient for your time zone. And the second cohort is going to start on June 21st, and that's going to be a little bit of condensed version because we wanted to, we acknowledge that, it's in the middle of the summer and you may have summer plans. So we are going to offer that cohort over a period of 2 weeks instead of 4 weeks. So it's going to be 21st and 23rd, and then 28th and 30th. We wanted to give a little bit of time between each of these modules so that you have a chance to kind of assimilate some of the concepts we have discussed in the class, and also come back with questions and interactions so that you can reinforce the learning over a period of time rather than getting everything in a 2-day setting. And the third one is going to be starting July the 27th, and that's going to be, again, a 4-week program. And that's predominantly geared towards people in the Asia Pacific region, and we have chosen the time zone which is more convenient for them. So that's kind of the gist of the program. Now, Richard, can we go to the case study?
Yeah.
Okay, perfect. So let me kind of set the stage on one of the case studies we built. And many of you know that earning call transcripts could be easily downloaded from the web. And the notion here is, how does natural language processing work? And I want to kind of give you an example to just illustrate for you, some of the things you have to do in order to get some of the analytics from these tests, from these earning call transcripts. And I'll also show you some code on how you can potentially go about building it. And when we do the workshop, we'll basically be able to elaborate on the case studies and the design and the whole thing. So this is just a sample earning call transcript. So you have a company basically having a Q&A at the end of it. This is Athena Health for people who know what Athena Health does in the United States. Now, I just want to kind of set the stage that, it's if you want to do something like sentiment analysis to interpret, some of these call transcripts at an aggregate level, there are multiple feeds available today wherein you can potentially just plug into a feed and then get the sentiments associated with a particular earning call transcript. Now, one of the challenges is many of these statements are very contextual. It's predominantly understood by financial professionals, and there isn't very much of emotion involved unless there are a lot of words being used either to express positive sentiments or extreme negative sentiments. But many of these statements, algorithms today cannot understand, and they may just bucket them as neutral. So we just wanted to kind of, validate that, assumption and see if we can do some analysis to find out how much can we trust the sentiment analysis indicators. And the biggest challenge is labeling of the data, because for each one of these statements, you could potentially assign a positive or a negative label, and then you will have these machines learn what the sentiments are when you put them into an algorithm. Okay, so just to give you a little bit of context, this whole area is what's called as natural language processing, which is kind of a confluence of three different kinds of sciences: the computer science, the artificial intelligence, and linguistics. And there are a lot of different applications you may be exposed to. You potentially are using Alexa or Siri or many of these chatbots, if you will. There are a lot of different methodologies which are typically used when you talk about natural language processing. Now, how is that applied in a financial setting? So guess what? You're already seeing some of these technologies implemented through various services, various financial institutions are already offering. Large banks are potentially leveraging NLP to summarize some of the information which is already there in terms of text documents. You potentially also have, consumer-facing applications like Bank of America's Erica, which is a chatbot which could help you to do various things in terms of account access or doing certain kinds of transactions. Now, one of the biggest challenges, obviously, as you know, when you talk about languages, is it's very hard to process from a computer's perspective. Even as humans, many times there are, accent issues. There are issues with respect to understanding, languages in different contexts. Now, the biggest challenge is how do you operationalize all these things, and how do you think about the possibilities and apply the right skills for the right job? Now, let's kind of think about a basic pipeline, if you will. And what we are doing here is we'll bring in the data, we will pre-process it, and just because algorithms are very hard with respect to building your own, especially in text algorithms, you have to have a lot of data to build a smart algorithm which can understand text. So there, we will invoke APIs. So these are basically interfaces through which you're going to ask Google or you're going to ask Amazon, to interpret what this particular statement means, and then we will potentially use that for labeling the data. And then we'll just compare some of these and build out a model. So let me kind of switch to a demo so that you can just get to see some of the kinds of interfaces we're going to use. The first thing is we have what is called as Q Academy, which we'll make available to all the participants, wherein you can run some of the code, you can try out examples, and you'll have all the content access, and you'll have access for the whole course material for 90 days. That way you can play around with these experiments. Now, this is just an example to illustrate that, you can potentially, take, this is from Seeking Alpha. So we took one of these earning call transcripts. So we chunked it so that you can see individual statements. And then what we're doing is we'll say, let's call a particular API and figure out what sentiments for each of these statements mean. And for that, we are going to be using Jupyter Notebooks. And this is just a simple example. And we'll talk about, how do we invoke these packages? How do we configure the various aspects of invocation of a particular request? And then how do we call these specific APIs so that you can get the requisite information and process it. So don't worry too much about the coding part, which we will go through as a part of the program. But let's kind of just focus on the outcomes, because once we go through this, we basically have a summarization of all we basically took each one of these statements and sent it to Amazon, we sent it to Google, we sent it to Azure, Microsoft. We also had two models we had basically pre-trained. One is a BERT and another one is a TensorFlow. And we asked each one of these models, tell me what the sentiment of this particular statement is. And we just summarized the whole thing. And that's what you're seeing in here. So you could see that most of the statements were bucketed as neutral. Basically, it meant that the computer doesn't really, the algorithms don't understand whether it was a positive or a negative statement. It said it's neutral, and most of them were bucketed as neutral. Many of them were bucketed as positive in here and negative. But the interesting aspect was, with the same data sent to different algorithms, for example, one of Google may have said for a particular statement that it's 20% positive, but the TensorFlow model said that more than 35% of these statements were positive. So just to kind of go into individual statements, you can delve into these statements and figure out like which ones were positive and which one was like the most negative. And you could figure out like, does it actually make sense? So from an analyst perspective, this is kind of what's actually happening behind the scenes, wherein you're basically taking at an aggregate level these statements and you're assigning labels to each one of them. And overall, you can think about, well, for a particular earnings call, overall, was this call positive or was it negative? Was it neutral? Which was like the most positive statement or comment? Which was the most negative? And you could potentially analyze that. And to note, this whole analysis did not require human intervention. You already had a pre-trained machine learning model, which was trained to interpret these statements. And what you were looking at was these invocations with new data and aggregation of it. And that's basically the power of data science and machine learning. So you're now able to build out a pipeline which leverages unstructured data, human communications, and you're processing them and then you're basically summarizing all this information. So this is just an illustration of one of the case studies. We will kind of go through the analysis. We'll give you like a step-by-step on what packages you'll need, how do you crawl, and how do you do all the fun stuff in terms of analysis, tell you a little bit about what are the various APIs available. And as we go, we'll kind of build upon your skill set so that you can start thinking about not only leveraging this API, but many other APIs as we speak. So that was a little bit of a demo. I know we are running close to the end, but I just wanted to end today's presentation with, if you're interested in joining this program, we would welcome you, and please let us know if you have any questions. We're going to open the floor for Q&A in a bit. But also I wanted to let you know that we are having the Alpha Summit coming up next week. And this Alpha Summit is an annual event and it's online this year. There are many programs and there are many sessions focused on big data and AI. And we will actually, Rich and I will share a session on some of the common questions which people ask when we talk about like data science. So we welcome you to join that session. And I'm also going to be moderating another session with focused on AI and big data. And because we are in this conference, the Alpha Summit conference is happening next week, we are offering a special promotion. And if you register between now and May 25th, using this code Alpha15, you'll get a 15% discount on the course, both for members and non-members. So I hope you are going to join us in the next few weeks, and I look forward to taking any questions. Thank you.
Sri, thank you very much for that. We have had a few questions coming in the chat. Actually, I think a general theme really is about how you can break into data science roles, specific data science roles within the investment industry, and related to that, how you can break into more general kinds of roles. So, for instance, a role in IBD, perhaps, but with data science skills. So I don't know if you can answer those two questions. So how do you think, if you're maybe a new graduate from university and perhaps you have a kind of a quantitative degree background, how do you get into a specific data science team? And then a separate question, how do you utilize data science to get into a role perhaps in an investment bank or an investment management firm?
Okay. So for the first question, I think the beauty of coming as a fresh graduate in today's day and age is there are tons of opportunities in the realm of data science and machine learning. And if you are interested in kind of building your skills, what I would think about is building a portfolio. And many of the the case studies, which we're going to illustrate as a part of the program, is to basically help you build a programming portfolio. Because guess what? When you go to an interview or when you want to get an opportunity in data science, most likely you're not going to be interviewed on concepts. You will be interviewed on your ability to realize those concepts with respect to code and how can you implement those. So in order to illustrate that you can not only understand the concepts, but you can apply those concepts in a particular setting, you need to be conversant with programming languages like Python. You should have demonstrated that you have built programs which does something similar to what they're potentially asking you, which means that you need to have a portfolio. And in fact, this is my 9th year teaching at Northeastern University, and I've had the pleasure of teaching more than 1,000 students, master's level students, who have gone and done great things in the industry. And they always come back and they talk about the project portfolios they built and they showcased it to their employers. And that's where you can show and lead the discussion to say, hey, I don't think that I understand the concepts. Everybody understands concepts, but I can operationalize them. I can actually build examples and look at my portfolio. Not only that I have understood these, but I have applied them in this particular setting. So that's a very good conversation starter. And there are multiple opportunities today for you to enhance those skills. And that kind of leads into the second question you were asking. So if you're very particular about investment banking, and if you are potentially interested in this intersection of data science and investment banking, what could you potentially do? First of all, once you understand a programming language, once you start building examples, you probably have a lot of access either at the university level or at an internship you're potentially doing, or even if you are already employed by an investment house, a large amounts of data sets. Now, you could potentially start with those data sets and start working on various examples. And for people who are new to the field and who are getting into investment banking and getting an internship or some kind of a position there is the most important thing, because that provides you context. If you do have all the skills, but you do not have the context, it becomes a big challenge to basically connect the dots. So you will have to look for those opportunities where you can operationalize the skills you already have.
That makes sense. Another question we had was really about what do you think will be the impact of data science or data science kind of on analysis versus traditional analytical techniques? In other words, will we see traditional analysis go away because of this data science revolution?
Yeah, that's a great question. And it depends on how much you're trying to leverage historical information. Many times you do not have historical information, right? So, you're looking at a particular company analysis. The company just went public last year. So you may not have a lot of public information available to analyze certain kinds of assets, if you will. So, but certain assets may be new. We are seeing so many innovations in cryptos and new fintech products coming out. So you may not have that history to leverage and build out models. So their traditional modeling is important if you're trying to calculate risk, if you're trying to figure out how our proxies or comparable assets similar to the ones on the question performed, and then potentially leverage those insights from proxies or comparable assets. And that's where traditional models does an excellent job, because you could potentially start building out your distributions and understanding the aspects from other assets or other families of assets, and then potentially extrapolate those towards newer assets. Now, when you have a lot of data, that's when the power of data science comes in, because now you don't have to assume things with respect to what the model will potentially look like. You actually have the data. You can potentially see how the models have performed in the past. And you could potentially build out more robust models and also build out better stress tests, better back tests to understand how things will go with respect to your operationalization of these models. So that helps you build out more robust structures. And I don't see them as two separate things wherein someone would say, oh, I'm only going to do traditional models, or I'm only going to do data science and machine learning models. You will see a confluence and a bridging of these methodologies wherein you will be leveraging data science to augment and to enhance your investment process. And that's where the world is going. And if you do not kind of, incorporate these newer factors, newer asset classes, newer, alternative data sets, you will be kind of, letting go of many opportunities which are out there to assimilate all these pieces of information in your investment research.
That's helpful. But a question too about how difficult it is to learn. In fact, a few questions around this. How difficult is it to learn coding, say Python, if you haven't coded before?
Yeah, that's a great question. I think the world is moving with respect to Python, though it started as a programming language with all the bells and whistles like many other programming languages, the power of Python is the ubiquitous availability of very specific packages. So you have a package for more or less anything. There's a package for optimization, there's a package for statistical analysis, there's a package for graphing and charting, there's a package for machine learning. So you have packages for various things. And what that means is you basically are now thinking about, how do I leverage this package? So here's something I want to do. I want to be able to pass in these as the inputs, and that's going to give me these specifics as the output. So now, more than you writing lines and lines of code to try and do certain things, it becomes more or less like a low code environment of sorts, if you will, if you're starting from scratch, if you will, to basically build out those interfaces so that you can start thinking logically to daisy chain the various processes so that you can build out your investment workflow. Many of the nitty-gritties or the details could be abstracted away, and you could kind of keep things at a very high level. And the world, the way it's going is you will see much more abstraction, and you will have many more easy to use graphical user interfaces, which means that you're not really learning the nitty-gritties of a programming language. You're just basically trying to operationalize and thinking about a language to structure your thought process. And you probably, because you're in that particular domain, already have a lot of context on how you want to structure your thought process. And just Python becomes the medium of operationalizing that thought process rather than thinking about it as I'm going to build everything from scratch. Mm-hmm.
So I guess other questions which kind of came about, I saw one participant was asking really about, is this kind of stuff being used in emerging markets? She used an example of Bangladesh specifically, but are we seeing this data science revolution happen globally, or is it happening at different rates in different countries? What's your view on that?
Yeah, that's a great question. It depends on the context again. There is no generic answer. In many developed countries, because of the access of technology, because of the access of high quality data, a lot more emphasis is now being put on data scientists and, kind of leveraging all this information which is out there. In various emerging countries, I think there are opportunities to basically create and innovate new products. When you think about emerging markets, one of the biggest challenges is the lack of data. And many a times companies are either doing, trips there to local sites just to understand, the industries and what's actually happening with the economy and all that good stuff. Maybe the reporting, structures in countries may not be as mature as some of the developed countries. So the timing and the availability of high quality digital data may not be there. But I see those as opportunities for companies and for entrepreneurs to create new data products. There is definitely an appetite for, international investing from throughout the world. And many times companies don't invest in certain areas just because of the lack of availability of the data. But if the data is available, if those opportunities are available, I think that would itself create new possibilities. In addition to that, I think there is an opportunity to kind of bridge the gap, because many a times what happens is starting from scratch is always a challenge. And typically what would happen is, if it's not like a manufacturing facility, right? So if I wanted to start a manufacturing facility in India, I'm originally from India, you kind of go through, understanding all the key specifics and building out the infrastructure and all that good stuff. But guess what? Why have software startups thrived in India? And the reason is there's a lot of lessons to be learned, which are coming from the developed markets in terms of delivery, in terms of access to the cloud in terms of security. And now you just need to use it as a blueprint and create infrastructure. And I think that's an opportunity for various developing countries to basically create mature products without having to go through the traditional innovation cycle.
Okay, that's very helpful. Just one, in fact, it's kind of a related, two related questions actually. So just as last questions, we've got someone who works for a firm he says they use PDFs and they use Excel to evaluate the data. So he's trying to imagine how can he transition that firm to utilizing Python and do that smoothly. And I think a related question is that someone's asking about how do I use Python to make pie charts? I mean, how do I make this quicker rather than just doing a simple pie chart, say, in Excel? So how can we kind of make a case that this stuff is actually going to make life easier and more effective for us? I think that's what kind of a theme of both of these questions.
Absolutely. I mean, Excel has its advantages for very specific kinds of data sets. But if you're trying to integrate, as I mentioned about APIs, right? So, if you want to integrate different kinds of APIs which are there in the world, if you're trying to do, research beyond what's available with the computing platforms. For example, in Excel, if I wanted to do optimization, then you had to say, okay, I need a solver. Excel comes with the solver, but I need to do additional stuff. I have to now integrate @risk or some other solver and start learning that, specific solver and then do my analysis. What Python gives you is the ability to generalize that process. And because it has a robust ecosystem of various, optimizers and various tools, you could pick and choose. I'm going to stick with my open source stack, or I could potentially leverage a vendor who is offering me data and has, this particular edge. So I'm going to be leveraging that data set. Or if I want to, just build my own, I can build my own. So you have a lot of flexibility there. And then the second aspect is you have the power of the cloud, because many a times, how many of you have sat and had a full cup of coffee when Excel was crunching certain numbers? Just because you're restricting it to the power of your laptop and you had a really large spreadsheet and you're doing some macros and you're calculating it, many times it crashes. So you're now stuck with infrastructure, trying to optimize with constraints and bounds which you may have artificially created just because that was the way things were done in the past. But with languages like Python, what it enables you to do is you can parallelize processes. You can leverage GPUs if you want to speed up calculations. So it opens up many more opportunities to kind of build your investment workflows.
Okay, that's really helpful. We also had a question actually from someone who was asking, how can I do kind of data analysis and visualization without using coding? And an answer was suggested, which is a good answer, is Tableau is a great piece of software for doing that. Another one is Power BI. Those are kind of growing software packages which do exactly that. So it's not as if the only answer here is coding, but basically then you're into a world of spending money on software packages. And I think a key part of Python is it's free, right?
Yeah.
Free.
That's true. But also Power BI and Tableau are not alternatives, that just enriches your visualization workflow, if you will. So they're complementary products. But Tableau and Power BI also have plugins to Python. So, I built calculators and, using k-means. So if I wanted to basically create a cluster of stocks and visualize them in Tableau just becomes a visualization engine. If I wanted to actually build out the machine learning algorithms, I could build them in Python and integrate it with Tableau or any other tool. So the analysis part is where Python excels in, and there's also like a lot of libraries for visualization, like Matplotlib, Seaborn, Plotly, et cetera, So you have the ability to interactively analyze. So it depends on what your goal is. So if you're providing a tool for an end user who is just drilling down the data, visualizing it in multiple fronts, and drawing insights and doing certain things, potentially just end user tools like Power BI or Tableau could be helpful. But if you want to be the analyst, you want to like dig deep into the data. Oh, I'm seeing certain elements in here. Let me look at the tail of the distribution. I want to do certain other things. So I think that the Python excels in that aspect because you have the power to get into the nitty-gritties and kind of answer the questions you're going to be interactively asking. And also, I think the world has realized that, with the power of Python, and I think the newer version of Python, which is going to come sometime in October, apparently on some benchmarks is 64% faster than the current release. So there's a lot of innovation happening to make things faster, better, and cheaper. Kind of going back to the first slide I had, which is the industrial revolution. The reason why it's a data revolution is people are realizing the power of the data, and you want to make sure that you have the right infrastructure to process all this information. So we should not be left behind.
That's right. I think that's a great note to end this on. Yeah, we should not be left behind. Things are changing. Things are moving very, very quickly in this space, as you'd expect. So, Sri Krishnamurthy, thank you so much for sharing your insights tonight. Very, very helpful. And thank you all to everyone who dialed in as well and asked questions and participated. We will be following up, by the way, with a link to the recording of this if you missed something and want to see it again, and some information also about exactly how you can register for this course. But no matter how you choose to develop your skills, this is very clearly an area where a bit of self-development and perseverance is going to pay dividends, particularly if you're in the process of starting off your career or want to evolve your career in this kind of direction. So thanks everyone for your participation, and you'll be hearing more from us on this topic very soon.
Thanks again, Richard, and looking forward to seeing you in class next week, in 2 weeks.
Great.
Thank you.
Cheers. Bye-bye.
Well,
excellent. Well done, Sri. That was very good. That was quite an engaged group, actually. Lots of questions. I was typing loads of answers to questions as you were speaking, actually. So there were plenty of questions coming from the group. And
absolutely. Yeah. So thanks again, Richard. We'll connect offline.
Excellent. Thank you. Bye-bye, everyone. Appreciate your coming.